I'm Dustin Stedman. I'm joined today with my group members, Samantha Killmer and Nick Johnson, and we're here today to talk about our capstone project for BTD Manufacturing. So first, we'd like to run through an introduction to BTD, just to give a better understanding of what they do and what they make, and then going through the 6 phases of our project. So an introduction to BTD, they were founded in 1979 in Bismarck, North Dakota. In 1980, they moved to Detroit Lakes, Minnesota. They have other locations in Lakeville, Minnesota, Washington, Illinois, and Dawsonville, Georgia. At the Detroit Lakes facility where we did our project, they employ approximately 500 people. The primary service they offer is metal fabrication through stamping, bending, and welding. And some of their key customers include John Deere, Polaris, and Caterpillar. So BTD's core values are focused around community, integrity, people, performance, and safety. For our project, we really hit hard on the performance and safety core values. So we laid out our project with this project plan just to give some tentative deadlines for where we wanted our phases to be, just to make sure that we were staying on track throughout the project. This is shown here in our graphic. So next, moving into phase 1 of our project with brainstorming. So for our brainstorming session, we started by having a tour of BTD from our project sponsor, Kevin Ronsberg. He showed us both their building 1 and building 2, just going through some of the different work centers, what products they make there, how material flows throughout the warehouse, as well as what equipment is available. It really gave us just a good understanding of how everything looks and how everything moves throughout the warehouse. So we could start, brainstorming ideas of what we were going to do for our projects and how we were going to accomplish it. We also looked into background research on material handling processes and lean processes. We ended up using the information we learned from lean processes to develop our 6 phases. So next, I will pass it to Nick to talk about phase 2 and how we created our charter.
So this is our team charter. We created this for the 3 of us to help throughout this project with scheduling, project risks, and any potential challenges we might have, and the steps we would take to get through these. For our statement of work, we began with our project of minimizing the time lost by forklift use, improving safety, and maximizing efficiency. We then worked into our current state map of the material flow and the tugger and forklift routes. We moved into our analysis and improvements, and finally created our future state map. Some assumptions we made for this project are outlined here. We assumed all employees are working with equal experience and training. We took a 6,000-hour work year between the 3 shifts. There is seasonally consistent production volumes. The desired cart capacity for the tugger is 5 carts. Bins are loaded to capacity by part size. And we also assumed that a greater job quantity would lead to a larger amount of parts being produced. And now for phase 3, Dustin will tell you about the development of our current state map.
Thanks, Nick. To start, I wanted to show some other pictures of the equipment that's used throughout the warehouse. I'll move from left to right. So starting with the far left picture is the tugger. Each of the 3 shifts operates with 1 tugger operator currently. They pull the carts pictured in the second picture with the bins on top. Most typically, we saw that they would be carrying about 1 to 2 carts behind them. But Kevin did mention that they can carry up to about 8 safely and effectively throughout the warehouse. The third picture is of the forklift. The benefit of the forklift is that it's able to reach the vertical racking where the tugger is not. However, can only handle one pallet at a time. Fourth is the Raymond. We didn't interact much with the Raymond for our project. We thought it was important to show the information anyway. They move along a small metal wire that runs in the middle of the aisle, and they're able to move along the thin rows because of this to retrieve items from upper racking. It's used just primarily in their inventory and storage sections. So the design criteria we chose to look at were safety, efficiency, and cost savings. By eliminating a forklift, we believe that we can make the environment safer just by reducing traffic. We believe that by having the tugger replace some of the work, that we can make it more efficient. And with efficiency comes cost savings. So for our data collection, we looked at production volumes, and these were broken down by the work centers, which will be shown next. We looked at staffing material handlers per shift, as well as equipment paths and working areas, and then tugger and forklift costs for maintenance. So here's the 2019 production volumes. The highest one was with hand welding, followed closely by parts bending and then tubing. The tugger currently already delivers material to hand welding as well as robo welding, but it does not interact with parts bending. And we believe that this would be a great opportunity for the tugger to replace some of the work if we remove a forklift. This is where the assumption came in that the higher job quantity leads to more parts being produced. We couldn't say 100% this is always going to be the case, but for our project, we chose it as an assumption. Next is the employees per shift. We wanted to show that shift 1, where we did our analysis, has the most employees with 41, compared to 28 and 26 in shift 2 and 3. Most notably that they operate with 3 forklift operators and 1 tugger, compared to 1 and 1. We believe that we can get this down to 2 and 1 while not sacrificing efficiency. This map shows the route that the tugger driver run through. This was observed through direct observation, watching where they drove and where they stopped to really see what work centers they were interacting with. The work centers that they were interacting with are circled in orange. And the path, he almost always would move from kitting through RoboWeld and handweld. It's a one-way from top to bottom. And then he would return either through the warehouse to drop off an unused jig, or hand weld and child parts to deliver parts to hand welding, or pick up more pieces for RoboWeld, or return to internal shipping or kitting.
This is our map of the shift 1 forklift routes. So you can see we have 3 forklifts listed here. The first one is in green, and their primarily service is machining. The second forklift primarily services the bending area of the facility. And the third forklift primarily helps with robo welding and hand welding. And while the tugger delivers most of the parts, this forklift helps in the kitting areas where bins may need to be picked up or set down, and at the end of the welding line where jobs are broken down and remaining parts are put back into child part storage. Next is our equipment cost analysis. We'll start with the chart on the left, and this is the cost for 1 tugger and 1 forklift. So as you can see, the operator pay, this is what the operators cost the company in total, including benefits, which would be $43, starting at the same level for both tuggers and forklifts. A new tugger costs less than the forklift, as you can see in the new machine cost. And the preventative and non-preventative maintenance is also cheaper on the tugger side. So this gives you the yearly cost after purchase on the bottom, which means it excludes any cost of a new machine. And you can see that the tugger is about $174,000 less than the forklift each year. Chart 2 on the right shows the total cost per 1 shift. So if you looked at the top line with 2 tuggers and 3 forklifts, That would give you a total cost of about $450,000 to run it for one shift for 1 year. Currently, BTD runs 1 tugger and 3 forklifts on shift 1, where our arrow is, and our goal is to get them down to 1 tugger and 2 forklifts. If we added up the current total of their current shift 1, 2, and 3, we would get about $719,000 per year. These charts show the cycle time and setup time in BTD's current operation, and this data is very dependent on the data and how accurate it is placed into the system. As you can see, some of the minimums are dashes, which mean a time must not have been recorded or was marked as 0. These numbers will not be directly impacted by our proposed changes, but improvements could be seen in the future. And now we arrive at our current state map. In this current state, we have 3 forklifts and 1 tugger driver. These colors all coordinate with the colors that were previously seen on the spaghetti map diagrams. In this model, we have our 3 forklifts in green, blue, and red, and our tugger in orange. So you can see the areas that they primarily service. Although the 3 forklifts do work together when jobs are needed to be done, for instance, in internal shipping. And now we'll transition to Nick to talk about the data evaluation.
Starting with our safety analysis, we looked at data for the United States forklift injury statistics. There are roughly 100,000 injuries per year, 85 of them being fatal and 31 of those being pedestrians. 35,000 of the 100,000 are serious, 20,000 are pedestrian injuries. The costs vary per case, but the indirect cost can be $150,000 or more. Indirect costs include uninsured costs like loss of production, property damage, and training a new employee. The direct cost can be up to $38,000 per injured person. During our efficiency analysis, we have a goal to have the tugger pull 5 carts per trip. As this happens, there will be increased efficiency for the tugger, and after the removal of a forklift, the other 2 forklifts will have higher utilization rates. The cost savings found in our analysis are listed here. We have forklift savings of $90,000 in maintenance and labor savings. The cost of our safety improvements are found in paint, caution signs, and a forklift camera system, and these will be discussed later. The yearly savings will be $90,000 per year, subtracting the proposed safety costs from the first year. This data does not include the potential savings of preventing accidents. Our 5th phase was to develop a future state map. Our future state map is similar to our current state map. The differences are that we removed forklift 2 and replaced it with expansion in the tugger area in orange, and forklift 1 and 3 will be supporting the tugger by taking over the vertical tasks of forklift 2. The black circle will be managed by both forklifts 1 and 3 as they are available. And now Samantha will discuss phase 6, the development of our implementation plan.
Thanks, Nick. So when we get into our implementation plan, we wanted to promote consistency across all shifts. So while we're going through these steps, please be aware that shift 1 will implement all steps of the improvement plan, while shift 2 and 3 will only implement the ideas of when to use a tugger and when to use a forklift, because they're currently already at 1 forklift. So step 1, explaining why. Explaining why is critical to make sure that everyone involved in these changes will understand why the change is being implemented. It'll be important to promote the increased efficiency and increased safety that these changes can see. This would be best done in a shift startup meeting to discuss the changes, the expectations of everyone affected, and then close with questions. It may also be a good idea to pull all material handlers aside for a separate discussion since they will be the ones the most affected. Step 2 would be the actual forklift reduction. So the idea here would be to remove the keys of forklift 2 that services the bending area of the facility. It would then be all of the vertical work would then be transferred from forklift 1 to forklift 2 to forklift 1 and or 3. This would need to be discussed on who's going to take over which tasks. The third piece of this would be to transfer all cart movement jobs that are horizontally done and can be done by the tugger to the current tugger driver. So communication through all of these steps will be very critical. We put together a list of equipment usage guidelines to help the tugger and the forklift operators. Some of the key differences is a tugger will utilize longer distance travel, where a forklift will utilize shorter distance travel. Another difference will be that material handling from a tugger perspective will be done on all horizontal movements where carts can be pulled, while the forklift should focus on those vertical movements when bins need to be removed or placed up on shelving or stacked or unstacked. So some of the more tugger specific details would be to transfer all carts related to welding and bending cells and to deliver the completed parts to finished goods inventory. This might have a change where empty carts are left in this inventory area and should then be picked up on your next trip up to deliver another batch of finished goods. So it would be a continuous cycle. The forklifts would focus on movement of those large materials or objects, and they would be contained to the designated areas where forklifts are required. Our third step of the process is the material request process. This is where all of the operators will really be tied together. We are going to propose that BTD uses the child part request list that they have already developed and can already be put into place. There's a graphic of this on the right side of the screen. The benefits to this is that it lists things such as the job number, the operation, and the details of the part numbers, and can be seen in a log type of format. Operators should use this request list whenever a station needs new raw material, whenever bins of finished goods materials are ready to be removed from the cell, or any other type of bin movement that a tugger is capable of. Providing training to all operators and material handlers on how to enter requests into this list and how to mark off requests that have been completed will be needed for all material handlers and operators. And we will need to enable all forklifts and the tuggers to have Chromebooks, which BTD has said most of the forklifts already have these. This list will be used to prioritize the deliveries. And the tugger driver specifically should batch requests when possible with a goal of 5 trips per 5 carts per trip. So an example of this would be when a bending cell requests new parts, as long as it's not urgent, the tugger could put that on hold until a few other requests come in from that bending area and then go make all of those requests at once. Step 4 of the process and any kind of change process would be to monitor and adjust. Daily meetings and discussions between the management and the shift employees will be highly beneficial here. And feedback from operators will be critical as they're the ones who will be affected and will see the changes the quickest. If issues arise, a root cause analysis should be used, and direct observation on the shop floor. An investigation will be necessary to see what the issue is and why it's occurring. And then, of course, we need to adjust as necessary. And now Nick can go through our safety improvements.
Thanks, Samantha. Our safety improvements address the key data found in our safety analysis. Pedestrians were a large portion of the fatalities and the injuries. Applying new safety floor paint and adding caution signs for areas with forklift traffic will help pedestrians be more alert in those areas and help prevent accidents. A continued emphasis on the current seatbelt requirement will help operators by preventing serious injuries and deaths from rollovers. The fork tine camera system includes a wireless camera and a screen for the operator to view. The addition of this camera system on the fork tines of the forklift assists the operator's vision to see exactly what the tines are in line with and to lower the chances of them making errors by hitting unseen objects otherwise. We would like to thank our project sponsors, Kevin Ronsberg and Josh Bass, as well as our professors, Dennis Steinman and Dr. Farmond. We would like to thank the many other BTD employees that assisted us throughout this project. So thank you for listening, and are there any questions?
Yes, of course I have some questions. So they've implemented a tugger system before. Did they have any insight into what some of the hurdles might be to try to eliminate one of the forklifts and implement this tugger system in other areas of the manufacturing plant?
So I guess I can answer that one. They did talk about, there's two different buildings. We were in building 2. They tried it in building 1, and they said for some reason it didn't work. We didn't dig too deep into, why it wasn't effective there. They explained that's why they have the second tugger available. But I think it came down to material size, whereas, in the parts bending and welding, the part size isn't as big of an issue. We might just have less parts per cart. But we believe that for the work that he's taking over from the forklift, that it should be possible.
And I know you said in your analysis you did not include the cost of the forklift. I think I remember that. Is that correct?
Our cost analysis, it was difficult to quantify how these specific changes, how much they will prevent these accidents and a dollar value that we could place on that. So no, we didn't include the cost savings of prevented accidents.
Yeah, as a note on that, you're talking about the future costs of purchasing a forklift in the future that they won't need to purchase versus a tugger. So something that they could probably take a look at, and they're probably not going to eliminate that forklift completely, but they're not going to ever replace it if it ever goes bad. I guess that's a note out there. How do you think the employees are going to take this, though? The forklift driver that now he's not going to be able to ride a fork, he's going to use a tugger. And I like your approach, talking to the employees, speaking with employees, bringing it up at the startup meetings and that type of thing. But just from a sense, how do you think that these forklifts are going to take that? They're going to lose their forklift job.
That was one thing that we had considered and wondered about ourselves, how that forklift driver would be affected. And so far in our discussions with BTD, that employee might not be riding a forklift daily, and we might not be adding a second tugger right away at the beginning of this project, so we aren't sure what BTD would plan on doing with that employee. I do think it would be a challenge for all of the workers, and why that communication would really be critical as why we're doing this. Why are you getting rid of that forklift driver? Did he do something wrong? We could see some of those questions coming up. But that was one thing that we think BTD will have to kind of work through, and I'm sure they have experience in the past with making some of these changes, and will probably implement similar strategies moving forward with this one.
I think this is actually a really good project because it's an exercise in determining the right tools for the right people. And if the tool, you know, why would you spend use a $28,000 tool on a project that you could use a $1,000 tool on? And I guess that's probably going to be pretty common when you go through it in your future too. Is why buy a tool that's really expensive when a less expensive tool can work? And that's really what you did here, forklift versus a tugger. The other question I have, so the fork cameras, you made a comment about the time cameras. Do they have any cameras on their forklifts now?
No, they do not.
Okay. So I don't remember seeing a cost analysis of the forklift camera times. Did you do any research on that or put anything together on that side?
I can-
Yeah, that was on the cost analysis.
Okay. Oh, they were there. Okay. So how receptive to something like that were they? Did you get a sense from them?
Yeah, they seemed to like the idea, and they had asked questions on the further details of what would be provided, and also inquired on how much it would cost, like here.
Okay. Good enough. I don't have any other questions.